So if you haven't done a CBM modeling project before, or even if you have, just the idea of it may seem very daunting. So why even try it? Because it is the very challenge of the project that makes reaching your goals so rewarding. It's like climbing Mount Everest. If it were easy, everyone would do it. But just like climbing Everest, the key to success is in the planning and in putting in the hard work. So in this video, I'm going to give you some tips on how to map out your modeling a protein story expedition to set your team up for success. Okay, so the first thing that you want to do is to decide on what the scope of your project is going to be. You might decide that you want to climb all the way to the summit. Or if this is your first year, maybe you just want to go so far with the intent of climbing to the summit in future years. This is something that you want to discuss and decide on as a team. So let's talk about the various parts of the program so that you can plan your expedition and then determine a schedule that will allow you to accomplish your goals in a timely manner. So the first stage in MAPS is a training phase that we call base camp. If you have ever learned anything about climbing Mount Everest, you'll know that you can't just climb the mountain and be successful. In addition to lots of pre-climb training, you begin your expedition with a very slow climb up to base camp, which sits at an altitude of over 17,000 feet. So what is MAPS Base Camp? So it's a series of molecular modeling activities that will prepare you to be able to model your own protein story later in the program. It starts with understanding how proteins fold into specific 3D structures based on interactions of amino acids with water and each other. You will then use this understanding to model a protein motif known as a zinc finger. This will give you practice using JMOL, the molecular visualization software that will help you design your protein model. If your team is experienced in protein modeling, you might decide to skip part or all of base camp. That's fine, but do so at your own risk. Spending a little time prepping early can be a huge help in being successful later. Next on your journey is to determine what protein you would like to study and to use to develop your protein story. We at the CBM have developed resources for 3 types of proteins: aquaporins, or the water channels, hemoglobin and other globins, and insulin. There are a lot of activities available for you to build your understanding of each protein and its unique structure-function relationship. From there, you can decide what related protein story you would like to develop. If you don't want any of these proteins, you can pick any protein you'd like. Just understand that you'll have to do a little extra research up front so that you can understand that protein well enough to develop your unique protein story for your project. So what exactly do I mean about a protein story? It's a deeper dive into your protein of interest to learn and model a specific concept that you and your team find particularly interesting. For example, I've had teams who have chosen the water channel aquaporin. After learning the general basis for aquaporin function based on its unique protein structure, they then decided to model a specific isoform known as aquaporin 4. What they found was that this isoform is slightly different from other aquaporins, and it is responsible for regulation of brain edema in the central nervous system. Or I've had other teams who have decided to model insulin. So insulin is really interesting because, as we know, it's a really important hormone, but it's also interesting because there's a lot of research being done on insulin analog development. So that means that clever researchers who know a lot about insulin structure function, they design what they believe will be a better insulin by making small tweaks in the protein structure in order to change its function just slightly. By making small changes, it's possible to make an insulin that you only have to take once a day because it lasts for a long time in the body. So that's pretty cool. Whatever story you decide to tell, just make sure that you and your team are excited about it because you'll be learning a lot about it. So often teams wish to find a research scientist to help mentor their team. This allows the team to ask the mentors questions about the science that they are researching and, when possible, visit their research labs. Having a mentor is great, but it also comes with responsibility. Your team will need to find a mentor who is willing to work with you. Then you will need to be respectful of the mentor's time because they are very busy people. Being professional and courteous will get you a long way. You can start working with a mentor very early in the process or wait until later when you've done some reading about and have some good questions about the science. But either way, you might want to work on confirming a mentor's willingness to work with you early in the process. One of the main goals of our modeling program is the design and development of a physical model. With a 3D representation of your protein, you will be able to understand the protein structure function at a higher level, and you'll be able to effectively communicate that story to others. The design process is done in a program called JMOL. You will find lots of resources for JMOL on our website that will help guide you. Just remember, in order to design a useful model, your teams will need to understand and agree on the protein story that you wish to tell, and then make thoughtful decisions on how to design the protein to best communicate that story. Once you finish the design process, you can then 3D print and paint your physical model according to your design specifications. Finally, you might want to present your work at some type of capstone experience, such as a local science fair or a regional or national conference. If so, you will need to know when this will be happening so that you can develop a schedule that will allow you to meet your predetermined goals by the time of your capstone experience. Okay, now that we have gone through all the parts of MAPS, it is time to map out your expedition and devise a schedule that will help keep you on track. So let's say you are shooting for an April 1st presentation event at your school. Okay, so that will mean that you'll probably be spending most of March working on your presentation itself. You'll probably want to give yourself a good 6 weeks for building your protein model. So figure middle of February to have your protein design finished and ready to print. You could then use a time from New Year's to mid-February to work on developing your protein story. In fact, you might want to do some reading over holiday break so that you are all ready to go when you meet again in the new year. That leaves the fall for base camp and researching your protein of interest. You could plan to get through base camp by the end of October and then work on researching your protein until break starts in December. Your team might want to agree on a protein story and a structure to model before you leave for break so that you can hit the ground running in January. But remember, this is just an example. Your team will need to make a schedule that best works with your project goals and your particular school schedules. So that should give you an idea of how to plan your MAPS expedition. Remember, you don't need to do all the parts. This is just to give you an idea of how it might work. It's really up to your team to make those decisions. We have an expedition planning sheet available on our website that will help you plan out your trek. It's meant to be a guideline. Things will happen and your timeline will change. Maybe you'll be very efficient and work much faster than you thought, or maybe you'll get behind for some reason. That's okay. At least you'll have this to help guide you and nudge you when necessary so that you know where you need to be and finish to reach your summit. Good luck and happy modeling.